Hey guys, we are looking at many inequalities here, and we want to write the solutions for these in interval notation. So let's see what these look like. Now, if you are being asked to write these in interval notation, you may or may not be asked to graph them. I personally like to graph them when I'm converting them to interval notation. It just helps my brain. But if you don't need to, there you go. Now, when I say graph, I use that term very loosely because this is literally what my graph is going to look like. -3 on a number line and 7 on a number line. Where did I get those numbers? Right there. So how do I figure out what numbers will work for x? That's what I'm trying to do. So this is actually an and inequality. Sometimes you'll see it written like this, and sometimes you'll see it written like this. So whatever number I pick for x needs to be true for both of these numbers, right? I could have written this one like this, right? Which my brain kind of likes that better, but I like the x on the left, but it's the same thing, right? All right, so when I'm looking at this, I'm going to go ahead and graph this. So I know that x, we can look at either one of these. I'm going to look at this one personally. X is greater than or equal to -3. So how do I show that on the number line? Well, here's my -3. It's greater than or equal to -3. So that means I'm going to use a closed circle because x can be -3 because of that equal to there. And it's all the numbers greater than. So I know it's going in this direction. But I'm not going to draw it all the way because I want to see how the 7 affects it as well. So x is also less than 7. There's no equal to here, so I'm going to use an open circle at 7. And it's less than, so it is going this way. All right, because this is an and inequality, it needs to be true for both of these. So even though like -500 would work for this one, it wouldn't work for this one, right? So that's why I cut off my graph. Now, if that's a little confusing for you, you could do it like this. Some people prefer to do it like this. Say x is greater than or equal to -3 and x is less than 7, and then figure out it's an and one and cut it off like that. So whichever way you like better, go for it. Now, this can help me understand how to write it in interval notation. So when we're writing in interval notation, we're giving a range of what x can be. So x can go from -3 to 7. But I need some way to show that x can be -3, but it can't be 7, according to my signs here. So in order to show that it can be -3, I'm going to use a bracket. And to show that it can't be 7, that's just like my border, I use a parenthesis. All right, that is my answer written in interval notation right there. Now, this is one way you might see it. Sometimes, a lot of times actually, infinity and negative infinity are included. Sometimes you write 2, so make sure you stick around for some more examples to see some other ways that we will use it. All right, so right here we've got x is greater than 12. Here is my very complicated graph. All right, so we've got 12 there. X is greater than 12. There's no equal to sign, so I'm going to do an open circle. And x is greater than or bigger than 12, so it's all the numbers over here, literally forever. There's no second one, so that is all the numbers x can be, anything bigger than 12. So how do I show that in interval notation? Well, my range of numbers this can be is from 12 all the way, x could be 500, right? It could be 7 million. It could be literally any number bigger than 12. So to show that in interval notation, I'm going to say x could be from 12 to infinity. All right. Now I need to show using either a parenthesis or a bracket if it can be those. So since it's an open circle and there's not an equal to, I'm going to use a parenthesis on 12. Now, infinity and negative infinity always get a parenthesis no matter what. You should never see a bracket with infinity or negative infinity. And that's because infinity is not actually a number, right? It's like a concept. So it gets a parenthesis, not a bracket. But that is this inequality written in interval notation. All right, let's go ahead and look at this third one. So again, we're going to draw our number line. Now, this is an OR inequality. So we just need to keep that in mind. Here's my number line, -6 and 10. And looking at the first one, we have x is less than -6. There's no equal to under that, so I'm going to use an open circle. And it's the numbers less than -6. So that would be going this way, right? Then let's look at our other one. Or x is greater than or equal to 10. So because there's that equal to, it can be 10. So I'm going to use a closed circle. Greater than or equal to, so the numbers bigger than 10 are in that direction. All right, right here is where it's important to pay attention to if this is an and or an or. When it's an or, that means x needs to either satisfy this inequality or this one. It doesn't have to satisfy both of them. So my x can be anything less than 6, or it can be anything greater than or equal to 10. The only thing x can't be is anything in between here. So how do I show that with interval notation? Well, this one we'll start with goes all the way from negative infinity to -6. Now, how do I show that -6 is not included? I use a parenthesis, not a bracket. Negative infinity always gets a parenthesis. But that's not all. Because it's an or, it also includes all of these numbers, 10 and everything bigger than 10. So I also go from 10 all the way up. It keeps going forever, all the way to infinity. Now, parenthesis or bracket, it can be 10 because of that equal to. So I'm going to use a bracket. And infinity always gets a parenthesis. Now, we do like to put a little u in here that means union. So it's telling you it can be this or this. So that is this in interval notation. It's important to pay attention to the and the or, because I want you to imagine for a second, if this or were an and, if it says x needs to be less than 6 and greater than or equal to 10, well, there would be no number that would satisfy that, right? These don't cross anywhere, so there would be no solution. If you want to see an example like that, I'll link a video in the corner. All right, last one. We have another and inequality. So here is my number line. The numbers we are concerned about here are 5 and 9. So x is greater than or equal to 5. So there's that equal to. So this is going to be a closed circle going in greater than, so the number's bigger than 5, so going in this direction. And then we want to see how the 9 affects it, so I'm going to write it all the way. X is less than or equal to 9. So again, it has that equal to, so I'm going to use a closed circle again. And it's the numbers less than, so in this direction. Again, because it's an and, I'm not going to count all these numbers over here, because even though it would satisfy this one, it would not satisfy this one. So I'm just worried about that range in there. So the possible answers for x go from 5 to 9, and they include both 5 and 9. So I'm going to use 2 brackets. All right, I'm going to link a whole playlist for you because there are some other ways these can end up if theirs are going the same direction. So make sure you check that out if you need to, but I hope this helped. Thanks.